Here we are, the very first roller that was produced in Germany a couple of years ago. We are holding it because this was a great excitement. Hundreds of people have been trying to make this roller. They gave up because their thinking was wrong. That's all that was wrong. They got the roller out and it kept cracking. That is my safety net. No one is going to copy that roller unless they're working full heart with me. You can spend as much as you like, and I would think there must be about £10 million spent by so many people trying to make that one roller. This is the magnetizing equipment. Here we are just making test models, so we don't need a very big machine. Again, you see another view. If you notice, there is a number of coils involved. This again is slightly different to normal practice. Another view of the coils. Another view. So anyone wishing to make these rollers, realize you've got to have a bit of patience, and I mean patience, and don't give up. Now, you may say, why can't you make it? Well, let's put it this way. If you make a house brick, you've got to buy the ovens and all the necessary equipment to make that one brick. That costs you a fortune. That's the same here. To make one roller, you may be looking at £12 million. So you've got to make millions of them, because after the first one, they cost very little to make. That first one is the bug. Here is the magnetic field around the first segments produced in Germany. By the way, these pictures are in the books, so those who want to study them more closely can do so. Now, here is the illustration of the SEG build-up. Can we show the plates with the pointer, please? You notice that is what we call the plate in which the rollers run on. That's what we call the roller, and these have to be slightly shorter than the plate, so they have free movement. We show here the coil which we build on the outside of the last ring, which supplies the final work. The only difference between this machine and the conventional machine is that this is the prime mover. The coils is standard practice. Notice we've shown 4 colors. That represents the different layers of elements which are compressed to form the plate. The same must apply to the rollers. The weight of, or the volume of the plate must be equal to the weight or volume, whichever you like to say, of the roller. Therefore, each roller in itself is a generator of its own. Here is a magnetic demonstration which so many people witness. There are letters in the books of people from Australia who saw this demonstration. This particular one is from the report of Gunnar Sandberg of Sussex University. Unfortunately, he gives you a slight wrong explanation. He says when you place the roller at the edge, it accelerates to its cruising speed. He could not tell you at instant go to the cruising speeds. The other people tell you in their report it goes instant to the cruising speed. Why should Gunnar Sandberg say it accelerates? The reason is this. He works in the electrical department of Sussex and he does not know. It baffles him. If I was in his place, I would say, this goes instant to cruising speed, but at this time I cannot explain why. But we will investigate it and tell you when we know. It would be much, shall we say, polite, much more professional than the way he went about it. You see, as we shall explain a little later why it goes instant to its cruising speed. Now this is the reason why the roller rotates. We have 4 elements. You see the color showing each element. What is happening, we have energized with DC, and on this DC we have used AC. The AC and the DC must be switched on exactly at the same instant. The AC must be at 0 point, and it must be on the upward climb. It must switch off at 0 point on the complete of a cycle. If you fail to get that right, the AC will erase the DC. But if you get that timing dead right, you're left with thousands of little pinpricks of forces. It is difficult at this time to say if these are true magnetic points, or whether we have got surges of electrons on one side and surges of holes on the other side. But one thing is certain, that if the plate and the roller are magnetized precisely the same, we have a strange position. And it says, you have got one pole there, but you don't have a pole there. The pole is over here. The next pole is above, that is not in line. You have a wave. What happens is that when you place the roller on that plate and you let go, the magnetic field lifts the roller. But at the moment this happens, eddy currents form. It pulls the roller down. If your sums are right, they balance to a point where the roller floats. It does not touch the surface. There is such a torque that the roller must rotate, and it rotates on its axis. Now, if we only have 2 lines of magnetic force on each end and 2 on the plate, it sits there, smiling at you. And that's no good to us. So what do we do about it? The answer is simple. Do something. I take the bar, I cut it in 8 segments. Now I do the energizing again on each segment. Now we have something completely different. We have still got the 2 outer ones, and they fit on the plate with the 2 on the plate, and the roller cannot move either way, sideways. But now, you see, we have gotten 6 more runs of these mysterious poles. They are exerting a force on the plate, so it accelerates. Another beautiful thing about this is you just drop it on the plate and away it goes. And they say, how did you do that? I didn't do it, that did it. I look at this and I say, why do we always take the hard road? Because when you drop the next one in, it just sorts itself out. It finds its opposite point to the one operating. Every roller must go the same way. No matter how many plates you have, they will always go the same way. Now the question is, how do we find how many rollers you want on the first plate? Because we obviously need to know that we got a steady output. Well, the sum is quite easy. You take square 3, you know the answer. You're all going to say 9. You're wrong. It's 9 fields. Every field has a value. When you calculate these values out, it is the sum of each column or each row or the diagonal. It's the answer to the material quantity you need. Every element is defined by that square that you're going to use. It is the right assembly of this material that makes this technology possible. When you do the magnetizing of each segment, if you got your sums right and you powder it with fine dust, you're looking at a magnetic field you have never seen. It is a bicycle wheel. It is exactly the spikes of a wheel. When you turn it up on its running edge, you just have this wave pattern. Holding it separate, that's nothing. There's no reaction, nothing. As soon as you put it on the plate, you have instant reaction. But it is instant. Whatever the cruising speed is, it travels instantly, it's free to go. There is no acceleration. We'll now take the next view. As you see, what we have is actually two waveforms going one direction, and then we actually got two others going in the opposite direction. We'll look at the next. Now, this is an enlargement of one of the plates, and this actually is a true plate. We give the measurements, we show you the ingredients we use. As you see, we use a rare earth at our outer edge. Then you see we use a nylon, and I like to say why I fancy nylon. We can use plastics, but in Germany we see, when I look at the finished thing, that the nylon, the plastic looks terrible crude. It looks hard, it looks brittle, and we believe that nylon gives a better finish. It's an insulator. It has a double gate. But there are three classes of nylon 66. That's what we call a positive charge. This is where the manufacturer takes away electron from each molecule. You can have a neutral, which is the standard one. Then you can have a negative charge. This is where they add an extra electron to each molecule. And it's the negative one I use. Next to that, we take an ingredient. It can be iron or any other of the magnetizing materials. And then on the outer coat, we put one which will not magnetize. But it must produce an eddy current when a magnetic field comes in touch with it. That is the basic of it. We'll explain how and why it works later. This is how the SEG looks. We only use 3 plates. You can use 4 or 5, but then you've got to consider if you're rich. If you're rich, of course, you can put more plates on. But this is a prime mover. It can be used as a home domestic power plant, which we are now developing. It can be used as a car engine. It can either be put straight in the wheels, or it can be put in where your engine is and 4 electric motors, 1 on each wheel. You've got the energy, you can run at mains, you can run higher if you wish. We can also use it for powering trains, we can use it for aircraft, and it is used on a very large scale to power our levity discs, as they were called. Here is basically what they look like. If you can consider a bull race, that's what we call them in England, that is exactly what you're looking at in this generator, except you do not need any housing or cage to hold them. This is one ring and the rollers, to give some idea of what we're talking about. This is a completed one. Here is the demo one in construction. As you can see, it consists of 64 struts. And let me tell you something. Boy, there were some problems to solve. You may think it's a very simple thing to put together. But when you're trying to prove to 400 scientists who said that such a structure cannot be produced, it will not support itself, let alone fly, you open the door to all the media to watch you do it. And then you see you have to solve this problem because we're going to use the weakest material we can get. Because if the weakest material can do what you say, then the stuff you select to do the job is indestructible. The scientists watch and they laugh. The television kept coming and recording every step of the work. The media was at their heyday. But slowly the scientists disappeared. They realized they had made a terrible mistake. You see, they said that the structure is a split beam system and it's too weak for the job we want to do. They were wrong. And by the time the craft was built, there wasn't another scientist present. And they never again wrote or said anything to me about what can't be done or can be done. Again, here's another view taken by the press of the Demo 1, so you can see how it is constructed. Now we can show towards the rim, down a little lower, now look up to show where the generator sits. Yeah. As you see, the generator I'm sorry, I'll take the mic. Yeah. Sorry, I'll get carried away and I don't realize people are not seeing. You can see all right? Yeah. Right. Now, where we're pointing all round is the generator section. And I can assure you, it is a very complicated thing to put in. Until you come to do it, you realize that this is something very typical. It takes about 8 people to pull each section in. Again, another press photograph. Here's another view. Oh, by the way, I'd like to say, one of the television crew said, we'll get up in a tree so we can film down because it's so beautiful. They got up, and when he got so excited, he forgot he was up the tree and fell. I have seen lots of funny things. I could write a book on the things that happened while we were doing this one model. Again, we're hoping you could get the idea of the construction. Now, the gaps in between are where the landing legs go in. Here's another view taken by the press. That wasn't the shot they took that it actually fell out. Now, that was a shot. That's, by the way, the man kneeling is Dr. Kane from NASA. He came and spent 2 weeks with me. He went over all the calculations, he watched a model demonstration, and he wrote a report. He sent me the copy of that report. He told the media present that he had examined everything. He's gone over all the calculations, and in his opinion, they were absolutely correct. On the demonstration of the model, he told the media that model could reach the moon in less than 9 hours. Now you compare that to NASA's effort. The Japanese scientists also wrote the book, and they also calculated out the effort of that model. They also said it would take under just 9 hours to reach the moon. And to ask the readers to compare that against the NASA's effort. This Dr. Kane ended his letter to all officials of NASA with the following statement. He said, if we do not marry Searl's technology, when Searl comes out on the world market, he will lead the world, and there's nothing they can do because they have no knowledge how to do it. Again, another shot taken from a tree, this time by another person. Here are part of my team. We have at the middle, it's Tony Justice. His full-time job was a tool machinist, and he used to come up on all holidays and weekends to help with the work. He was a great lad. We have to the right of him is Gordon Goodfellow. He, by the way, was glad he is not meeting his Lord. When I met him first, he was in a terrible state. He said the hospital cannot do no more for him. He had a short time to live. He had severe bronchitis and asthma. So I said to him, I'll have a spare generator. I will bring it over and fit it up in your home. 2 days later, when I went to his home, he said, boy, I get all my family around this. He said, it's like drinking lovely spring water. He said, I feel good. 4 weeks later, he said, can I come up and join your team? So we brought him up, and he said, oh, I can't do this. I said, watch. Let's watch how we do it. The following weekend, he was in the team, working just as hard as the rest. The question is, we can never do anything that's strange, but if we stand and watch other people who can do it, we all can do it. And that applies to every one of us. We have to see how we do these things. This is a view taken above of the cabin of the Demon 1. In fact, I often got in it for the press to take pictures. You can, there's plenty of room to lie in it. It was 21 feet in diameter, and it weighed 12 tons on completion. We have started wiring up under the cabin floor for all the control apparatus that would be used for the radio control side of the craft. We only just started to throw in the leads. They actually go through to the generator. I don't know if you can show where the cables are running through. And we just had to string them up because we had the media present, and they take all day filming. Right. Again, we have the colour shot taken by another freelance photographer. Again, showed you how the structure of the body is done. Again, another view, the shell has gone on. Now, we had a problem here. If television was going to show this craft, the last thing we want anybody to say, you've got batteries in it. Now, we actually had a scientist who said to Louis Giro, when he demonstrates again, look to see where the battery is. Now, do anyone know what battery is available that can lift a 12-ton lump of material? If you do, please tell me where I'll get it. And of course, I like to point out, in a video which we have released for 4R1, we are on daytime live, and the scientist is demonstrating. He winds up his little flywheel effort, and he released it. And he said that, I believe that John Searl whipped this up and got up a high speed, that it lifted up and then fell over in the ditch next door. So I asked Louis to write to him and tell him, we invite you to come and twist this up and let it go. We never had any reply. On the television program, at the end, if you get the video, the interview was very funny. He was rubbing that scientist quite hard. And then he said, you people never believe anything unless you see it. So he said, if John comes and he hovers a 3-foot thing in front of me, I would then believe it and have a part of the action. So we have informed him. We'd like to do this for him, but there's a bug. We have to have it outside. It'll have to be on a very long lead. You see, we have to get it off the ground a bit more than 3 foot. But we'll have a crane. He can get up on the top of the crane so he can be 3 foot from it. And he can sit there while we're doing the next program. And he can sit there until the battery runs out. But of course, I could talk to you for hours, for days, about the things that have happened, what the experts say, and when we show them, they pull their hair out and can't answer. Again, another shot taken. That's the demo one, the one that's well known all over the world. Again, another view, we have Tony Justice on top, and it looks like we have the girl that did all the wonders for the papers, who stood on top for their pleasure in the shortest of clothes. I always said to her, you could do what you like. You can get on naked if you want to, long as the cameras get the picture of the craft. She was a good girl. She did everything she could without breaking the law. Now, this was an interesting news article. Every so often in England, we have what we call the UFO sky search, where everybody goes running out to different areas to watch the sky. And the media point this out. What they're really saying here in the article, only a saucer ride away, we were testing our latest craft. That, by the way, is the wonderful girl that went to great lengths to keep the cameras flashing. Again, another press photograph. In fact, that one was recorded in many newspapers all over the world. That is perhaps the most used photograph in the world. I think no matter who sent me articles all over the world, books, that photo is in it. That, by the way, is the P11 on test, and I like to point out an 8-force wind girl was running. The reporter's asking me, how on earth does that keep still? And I am explaining to him that those white sections, can we put the flash on the lower part? They're the sections of the body that's been open. What we're doing, we're using the gale force 8 as one field, and we're using the lack of field on the craft as the opposite. And we reverse this to the back side of the wind, so we're holding it dead still. And we held it for an hour to show them it won't move until we change the conditions of the craft.
What year was that?
That's about 1968. This again is about 69, where the BBC wanted us to do a demonstration. And this is what they did. They hired 2 helicopters. They had cameras made in Germany, especially to go out on a boom. They paid £80 an hour for each pilot. And they believed, and I did tell them they were wrong, but they said they were right, that they would capture that craft taking off across the country to the final marker that they were setting up for the test. And that would be time check. The cameras were in place, and they say, well, John, we're ready. You're sure? Yes. All right. So I gave the command for the engine to speed up, and she took off. I didn't put no support weight at the top. And boy, it went. And within 3 seconds, we got the call from the RAF radar to say that it is at the height for the test run. So I swung it round and sent it off to Cornwall. They missed it too. At Cornwall, we were notified that it had crossed the point. We returned it back to Mortimer. The time rested. All the money they spent was a sheer waste of time. We were lucky, 2 or 3 camera people did catch it from the ground. But as you can see, there is a large electric pylon in the background. The speed of this compressing the air distorted completely the background pylon. We're not sure whether it actually rained from that compression. It probably is, but we couldn't get near enough to check. We were all too busy. Now you may wonder, what was the record time? The record time was that between Mortimer and the edge, the end landmark of Cornwall, it took 3 minutes to get there. Well, I would say we're looking at about 100 odd miles. And that was a model being withheld from the maximum speed. It wasn't touching anything. We were only just satisfying the media what it could do. And that was only a model.
Did it make a sonic boom at that speed? Sonic boom? Did it make a sonic boom?
No, because it's forced a tunnel. We'll be explaining this a little later. Here is, somebody caught this picture, they shouldn't have got it, but here's the transmitting equipment. Away in the distance, we are bringing the craft towards us. Now, I think many of you would be very interested in what you see in a disc shape. If you're shown a photo of a disc, if it's completely circle, the person taking it is looking straight up. No other point will give you a circle picture. We know, we have thousands of photographs. If they say that they were standing so far away, then that picture is a fake. If you see an elliptical shape picture, and they say they were underneath it, that's a fake. For elliptical shape, you have to be some distance away, and you're taking it at an angle. If you see a diamond shape, then that particular shape is coming right sort of diagonally towards you. And it's the way the centered diamond look tells you which diagonal route it was taken to the person taking the picture. If you see it as a long strip, then it is shooting past you. It is going parallel to you. Simple little pictures tell me a lot because we have put crafts to the test to find out how they look in a photograph. Now, this particular picture is taken from another craft. We have taken up because a lot of the people at the show wanted to know what it looks like from above. So we've taken the craft up and taken a shot. We also have taken the craft down and taken a shot from underneath. Is that on the next shot? Now, underneath is completely black. Now, that's because the way they have taken it. There are points where you take it, where you can see the mirror image of this ground condition, whether it's trees or whether it's big lumps of ground, it will color it. It acts like a mirror. When you see it's with nothing mirroring on it, it means that the person was standing at such an angle that you can't see the mirror image being projected by the bottom of the craft. Here's another view taken by the second craft from the top, because we took 2 or 3 at different points, so that people can see it still remains that particular condition. And the best, we took them in the evening so you can see it. That's another shot taken from underneath. Again, the person taking it is obviously at a diagonal to it, so you cannot see the mirror image on it. This is Schiphol, the airport I did my international flying in when I took passengers to add weight to the aircraft. And as you see, we are projecting the 21st century. Schiphol is actually developing as a new section to the airport. And I think you will realize that the 21st century is going to look quite different to what we know.